Oh, did it see you there? My name is Arthur Zamuku, and today this is my science project for the video. And today we're going to be learning for chapter 13, 13.1, and 13.2. Those are called work, power, energy, and work energy theory. So in this laptop, I searched it up, and look it up. So in this video, we will be talking about work, power, and energy. So we started with power. What is power actually? Well, power is equivalent to work divided by time, which is, well, the unit for work is actually joules while time is seconds. So anytime when work is done, energy has been transferred. So power acts like a rate for it, which is where energy is transferred from it. Let's say if we have 100 watts, which is watts is equivalent to 1 power. Since power is equivalent to joules per second, we could say 100 watts is equal to 100 joules per second. Now the next one will be work. So the equation of work is actually mass times gravity delta height. Also, always remember, gravity is equivalent to 9.8. Let's have a demonstration of the equation. We have a diagram that shows two people lifting an object weighing 50 kilograms. Their name is Joshua and Marvin's, and they are gonna lift the object around the height of 2 meters. So now the question is this: what will be the work of this diagram? Well, the work of the diagram would actually be work equals to mass times gravity delta height. Since we know how to use the equation, we will use 50 kilograms times 9.8 for the gravity times 2 meters. Then it will be equivalent to 980 joules. But let's say it takes Joshua 10 seconds to lift the object, while Marvin's take it 1 second to lift the object. To solve that problem, we have to use the power equation, which is actually power is equals to work divided by time. So in Joshua's case, the answer would actually be 98, while in Marvin's case it would just be actually 980 joules, since divided by 1 is actually just 980, and divided by 10 is actually 908. So guys, that's it for the video. I hope you enjoy, and please take it.
FBI, you're under arrest!
Wasted!
Is this what you want? Come on, strike me down, Zeus. You don't have the ball.
Before we get any further, why 13.1 isn't fully explained? Because it isn't my main or actual part. It is just a short review that could try to explain a bit about the main part, 13.2. Are we cool? Now let's go with work energy theorem. Let's say you constantly pull a box at a rest on a wooden floor. In this figure, your constant pull or force does work on the box, causing the box to speed up. Since the box is speeding up, the box accelerates and kinetic energy increases. On the other hand, in this figure, it illustrates a negative work done by stepping on the brakes of a car, resulting to a decrease in kinetic energy because the car slows down. Now to solve any of these types of problems, we're going to be using the equation of the work energy theorem. It's going to be force times distance equals to 1/2 mass velocity final squared minus 1/2 mass velocity initial squared. Now let's have a diagram. A 45 kilogram box initially at rest is being pushed with a force of 950 newtons along a frictionless horizontal surface. What is the speed of the box after traveling a distance of 2.0 meters? First, we find the different variables. We have mass of the box is equivalent to 45 kilograms, force applied is equal to 950 newtons, Initially speed is equivalent to 0 meter per second. Distance traveled is equivalent to 2.0 meters. But the question is, what is the final velocity? Now we use the solution. Since initial velocity is 0, we could take it out early, since it would be simpler to solve the problem. Since we are trying to find the velocity final, we now try moving other variables, except velocity final. We first take out the denominator, so 2 times p times d, and then 2 times 1/2 mass velocity final squared. Then we multiply, and we get 2pd equals to mvf squared. Now since there is still a mass left out beside the main focus, final v, we do the similar thing with the multiply 2 part, but instead it's 1/m, since only a numerator. So we multiply and get 2pd over m equals to velocity final squared. But it's not yet done. We are finding vf, not vf squared. So we find the perfect squared by using square root. So it would be, the outcome would be vf is equivalent to 2pd over m. Now put it the square root, it would actually be equivalent to square root 2pd over m. Now we replace those variables with its number counterparts. So we get final velocity is equivalent to square root 2 times 950 times 2 over 45. And we multiply that and square it, so we get Vf is equivalent to 9.2 meter per second. So the final answer is the final velocity is equivalent to 9.2 meters per second.
FBI, open up!